In the previous video, we looked at persistent volumes, and in this video, we will look at how to specify configuration data in Kubernetes. Most of the applications deployed in Kubernetes would need some kind of configuration data, such as database connection information, logging level, application parameters, and so on. In the Spring Boot application that we deployed earlier, we would specify database information if required in application.properties and logging information in logback.xml. When deployed to Kubernetes, we would want the information in those files to come from the cluster such that the configuration can be changed without rebuilding the application. We might still have to redeploy the application unless the application is designed to reread configuration every few minutes. Another advantage of separating out configuration is that it allows maintaining configuration for different environments as code and then injecting the configuration for the appropriate environment based on the deployment parameters. For example, the hem package manager can externalize configuration by passing in an environment-specific values.yaml file during installation. By separating out the configuration from the application, it becomes much more easier to deploy the application to various environments and to also promote an application to the various environments. Config maps are used to provide most of the configuration information to Kubernetes, except for sensitive information which is provided through secrets. We will look at secrets in the next video. There are two ways to consume configuration information by an application. The first is by passing the configuration info as environment variables in a pod. In this case, the config map needs to be created before the application is deployed. Changes to the configuration are not reflected in the pod unless the pod is restarted. The second way is to mount the configuration as a volume inside the pod. For example, we can mount the application.properties and logback.xml files inside a directory in the pod. We will now look at config maps in action. Here's a modified application.properties file that contains basic database connection information. Look at Spring RESTful API kube config map project in the course's GitHub directory for the application. The Docker image for the application is at /spring RESTful API kube config map. We'll start by externalizing just one property. Let's say we want to create a config map that contains the database username. This is how we do it. kubectl create config map Spring RESTful API kube config map from literal Spring datasource username equals config user. This is how the config map looks. The actual configuration information is in the data section. To make the username property available inside the pod as an environment, we modify the deployment YAML file to add the env section. The name of the environment is the name of the environment variable. We tell Kubernetes that its value comes from a config map whose name is Spring RESTful API kube config map, and from this config map use the key spring.datasource.username. There could be multiple configuration parameters inside the config map, and therefore we need to specify a key. We will now deploy our Spring Boot application. It will get all properties from the properties file except for spring.datasource.username, which will be overwritten from the environment variable that we just created. We have created an endpoint called datasources that simply prints the JDBC variables that we set in application.properties. To deploy the application, we type in kubectl apply -f kube spring API config property file.yaml. Let's call the data source endpoint and check if we can see the property that we injected. We can see that spring.datasource.username is config-user, which is the one that we pass using the config map. Another way to create configuration is from a properties file. Let's create an application properties file that contains all three properties. We create a config map from it by typing in kubectl create config map spring RESTful API kube config map file from file equals application.properties. This is how the config map looks. The data section contains one key called application.properties, and its value is the entire properties file. To use this config map, however, we need to do something different. Instead of passing the properties in the environment, we tell Kubernetes to mount the properties file in a directory inside the pod, and then tell the Spring Boot app to use that directory as its configuration location. Let's see how to do that. The first step in mounting the config map as a volume is to create a volume. We add a volume section in the YAML file and name it application-properties. We populate the volume using a config map that we just created using the application.properties file. The items section tells Kubernetes to use the application.properties key from the config map. Path is the path or the file name in the mounted volume that will contain our config values. The next step is to create a volume mount for the volume that we just created. Application-properties is the name of the volume that we just created, and mount path is the path on the container where the volume is mounted. A Spring Boot application container now has the application.properties file at /opt/config. We still need to tell Spring to use that path as its config location, and we do that by setting in the environment variable called spring.config.location. Spring Boot looks for this environment property and if available uses it as its configuration location. Let's deploy our application again using the kubespring API config property file and hit the data sources endpoint. Data sources returns the properties from the application properties file that we mounted as a volume. This finishes our video on config maps. To recap, we learned how to create config maps and how to make them available to a container as environment variables and as a volume. In the next video, we will look at how to store and make sensitive information available to the container using Kubernetes secrets. See you in the next video.